In this demonstration, we're going to observe OSPF routing protocol communications between router R1 and router R3. I'm connected to the network from PCC, and I have a console connection to router R3. Currently, the network is almost completely configured. Attached to router R1's gigabit 0/1 interface, we have the 192.168.1 network. Between R1 and R3, on the serial point-to-point connection, we have a 192.168.2.252 network, and attached to R3's gigabit 0/1 interface, we have the 192.168.3.0 network. I've configured OSPF on router R1, but I have yet to configure OSPF on R3. So the first thing we'll need to do is configure OSPF on R3. Once we configure OSPF on router R3, R1 and R3 will be able to exchange hello packets and establish an OSPF neighbor adjacency. R1 and R3 will be able to exchange with each other their link state information and learn about networks not attached to their interfaces. For instance, R1 knows about its connected networks here and here, but it doesn't know about the network coming off of R3's gigabit 0/1 interface. And in turn, R3 knows about the networks that are connected to its interfaces, but it doesn't know about the network coming off of R1's gigabit 0/1 interface. So once the neighbor adjacencies are established, the routers will be able to learn of each other's networks and add them to their respective routing tables. We can observe the OSPF protocol in action from our console connection from PCC to router R3. I've opened TerraTerm and I have a console connection to R3. I'll put in the password Cisco, the enable command, and the password class. Let's take a look at our routing table. I'll do a show IP route command, and you can see that this router R3 has in its routing table the 192.168.2.252 network because it's connected, and it knows about the 192.168.3.0 network, which is also connected, but it doesn't know about the 192.168.1 network coming off of router R1. Let's turn on the OSPF routing protocol and see if R3 can learn about the one network coming off of R1's gigabit 0/1 interface. I'll go into global configuration mode, type router OSPF and the process ID 1. I'm going to set the router ID of R3 to 3.3.3.3. And now it's time to add our networks that we want to advertise with the OSPF routing protocol. I'll start with network 192.168.3.0, put in the wildcard mask, and area 0. Next, I'll add the serial network between R1 and R3, and we should see the two routers begin to communicate immediately. 192.168.2.252, the wildcard mask, and the area number. And you can see immediately a notification message from the router with an adjacency change. Router OSPF process 1, you can see that the message is coming from R1. R1's router ID is 1.1.1.1 on serial 0/0/0 from loading to full. This indicates a full adjacency. I'll type end and issue the show IP route command again. And you can see that R3 has now learned about the 192.168.1.0 network. O indicates that this route was learned from OSPF. Let's issue a show IP OSPF neighbor command. You can see that we now have an OSPF neighbor. The neighbor ID 1.1.1.1 is the router ID of R1, and you can see the state is a full adjacency and its IP address 192.168.2.253, coming off of R3's serial 0/0/0 interface. Let's see if we can watch OSPF in greater detail. What I'm going to do is disconnect the Ethernet cable from R1's gigabit 0/1 interface. But first, I'm going to turn on a debug command so we can watch the OSPF protocol in action as it loses connectivity to the 192.168.1.0 network. If OSPF is functioning correctly, it should send out notifications that it no longer has a one network and inform R3 of this change. From the console connection to router R3, I'll put in the command debug IP OSPF SPF to see if we can get some real-time debugging information from the shortest path first algorithm. I'll turn that on, and now I'll disconnect the Ethernet cable to R1's gigabit 0/1 interface. We should start to receive messages, and there they are. You can see that the change in the network topology has been detected by OSPF, and OSPF protocol messages are being sent between R1 and R3. If we scroll up, you can see here that it is initializing to run the shortest path first algorithm. You can see that link state advertisements are being exchanged, and you can see from down here at the bottom that routes were added for the 192.168.2.252 network and the 192.168.3 network, but not for the 192.168.1 network, which we have essentially lost contact with. I'll reconnect the cable and we can watch the routes come back into the routing table. The cable's been reconnected, and you can see the real-time information as the networks are being added. Adding stub nets route update succeeded for 192.168.1.0. All of this output happens in real time as R1 and R3 exchange OSPF messaging, link state advertisements, link state updates, and link state acknowledgements. I'll turn off debugging and look at the routing table once again. You can see that the 192.168.1.0 network was successfully re-added into the routing table.